Wolff from the Open University. I'm also talking on behalf of my colleagues and ex-colleagues, Zdenek, Andriy and Michal. I'm presenting some of their work. And what I'm going to talk about is predicting students who are struggling in order to hopefully provide a timely intervention and improve retention rates. And the work is done using data from the Open University, which is a distance learning institution. Okay, so the problem with students is they don't always necessarily come and say that they're struggling. They don't always even realise it for themselves. But it has been shown that if you contact them, this can have a really good response in improving retention. Obviously, tutors don't always have the time to go around asking every single student, are you okay? Is there anything I can do for you? So recognising who is struggling in order to work out who's going to benefit most from an intervention is obviously very useful. So, as mentioned, at the Open University, we offer distance learning. This means that the learning doesn't take place in a traditional classroom. The tutor doesn't get to see people face to face, and this makes it particularly hard to know who is in difficulty. So, students interact with the learning materials through the VLE, and contact with the tutors is generally mediated also through the VLE. This is where the tutor can look and see what's going on, but how do they interpret the data? How do they really know what's happening if they can't look behind and see? The solution is to develop predictive models on the student data from this data source and other data sources, as I'll go into, and then use this to predict which students are struggling and then visualise this in some useful way to the tutors and allow them to decide, on the basis of that data, who's going to benefit from an intervention. The data sources we were looking at are from the virtual learning environment. So this includes data such as logging in, looking at learning materials, going onto a discussion forum and chatting, possibly just chatting with friends or hopefully chatting about the learning materials. There's also online quizzes, and there's also other things that can be done through the VLE, such as updating your personal details. So it's not all learning tasks on the VLE. Students also produce data about their assessments in OU courses. There's continuous assessment at certain points in the course. There'll be a tutor-marked assessment, and we have data from this to know how the student did. At the end of the course, there's a final exam. So the mark from the continuous assessment plus the final exam goes towards deciding their final mark, whether they've passed or failed. There's also demographic data, so we know, for example, how old they are, what their gender is, where they live, and various other things like this. So these were the three data sources that we focused on for developing the predictive models. We used historical data, because obviously with historical data we know what the outcome was. And we chose three courses to develop the models on, which were fairly typical in how they used the VLE. And they also had quite a large number of students that logged in and used the VLE for those courses. This is what the data looks like from the VLE for one of the courses, and along the x-axis is the weeks that the course was taking place, and each bar on the bar chart represents the number of clicks, total number of clicks in that week. The red bars along the bottom represent tutor activity on the virtual learning environment. And the tutors are fairly consistent. They work hard all the way through the module and obviously don't have any time to be calling up people and asking them how they're doing. The students, on the other hand, they tend to start out fairly enthusiastically clicking away on the VLE, and over time, the general pattern, as we've seen repeated, if I showed this for other courses, it's always the same. It tails off. What's interesting to note here, and we also see this on the other courses, is that there's a peak of activity at several points during the course. This represents a time when the student has to do a tutor-marked assessment. So, as we all know, a lot of people do it at the very last minute. They do a lot of learning. They have to go in and they have to submit the assessment. And we see this as the peak of activity. Now, it would be tempting to think that looking at data like this, we can find out how many times a student should click. And if they haven't clicked 50 times in the first week, they're probably going to do badly. But this isn't really the case. We can have students that click very little and end up doing really well, and we can have students that click all the time and end up doing really badly. So This is why we need to develop predictive models that are a bit more sensitive to exactly what the students are doing. So a brief overview of how to build a classifier in case there's one or two people here that aren't too familiar with the methods. The first thing you need to do is work out what you're trying to predict. So in our case, we were trying to predict if a student would either pass or fail at the end of the course, and we also wanted to predict if the student would drop below a pass mark level at a certain point in the course with their tutor marked assessment. So the pass mark is 40. If they dip below 40, this could be a risk factor. The next thing you need to do is select the features to build the model. It's tempting to think that you should put in all your data, but that's not true because for example, as I mentioned before, in the VLE, there's certain data categories you might not want to include, such as if people are updating their personal details, or if maybe you don't want to include the forum activity. So you need to do a certain amount of pre-processing and to make some assumptions and test those assumptions as part of the building of the model. And you also need to decide if there's any data points or students that you want to omit. So, for example, some students don't necessarily use a virtual learning environment but get all their materials sent through the post. So if you include their other data, such as TMA data, but not the VLE data, then you might skew the model that you're building. So you need to think a little bit about your data first. So once you've chosen the features, then you need to choose an appropriate method or a classifier. We tried we did support vector machine, SVM, and decision tree. The support vector machine takes the vectors and plots them in space, and it tries to make a boundary between, hopefully, your two distinct data sets. And once it has a boundary on your test set, you can then run unknown data through it and find out which side of the line it falls. And this is your prediction. Obviously, you're using historic data, so you know whether this is true or not, so you can then get some idea of how accurate your model is. Decision tree works slightly differently because it tries to find which are the important features in your data set which can be used to distinguish your classes. So at the top of the tree, you get probably the most informative feature in terms of determining who's going to pass or fail. And then it's like these, we're all familiar with these things where you go down a tree answering yes or no, and depending on your answer, you get another decision to make. So it develops this and it builds it based on the optimal nodes at each point in the tree. We found that for our data set and our particular problem, that the decision tree outperformed the support vector machines quite dramatically. So just to give a bit more detail, the particular algorithm we used was Quinlan C4.5, which is a variant of ID3 decision tree learning. And the features that we used to build the model were specifically the clicks in the time periods, which were the times in between the assessments, with different window sizes, so that if we had window k equals 3, we would do the clicks at the time we were trying to predict, and then in the 3 TMA periods between that, and we would count the clicks. We used the assessment results, and at some point we also tried to add in some demographic data. And as mentioned before, the class was either pass or fail, or whether they were going to have a performance drop in their next assessment. And we tested it to find out how accurate it was using the method tenfold cross-validation. And we had pretty good results, focusing on the F measure, which combines the precision and recall. For the 3 modules, predicting performance drop was fairly, given that the higher number is better, I mean, it was fairly good for all 3 modules. And this model was actually built without doing a lot of data processing that we've subsequently done to improve this. Similarly, the final outcome, we were able to predict. This graph shows how the best data was the TMA data and the VLE data combined. So you could do some prediction with the VLE data only. That was okay. TMA only was not so good overall, but when you combine these 2 data sources, it was very powerful for predicting the failing students. We added in the demographic data, and this does improve prediction to some extent. So when the module starts, it's really useful to know what students are doing in the VLE. This is the most informative. Demographic data does improve prediction, but after some history of the student on the course, so for example, after they've done 3 or 4 assessments, then their assessment result is the most important for predicting their result. So this goes to show how you have to understand what the different data sources contribute at different points in time. Our additional results were that we applied the same model from one presentation of a course to future presentations of the same course. So without rebuilding the model, we tested it on an entire presentation and we still got good results. I haven't blinded you with more tables and data, but this is all in the paper if you want to go and see exactly how good it was. We even applied a model built on one module to data from another module, and we also received good results. So this suggests that it was a fairly robust model and that the results and the features that had been picked out as being important were fairly transferable. And the most interesting finding, and I think this really is the key finding, was that what you need to look at is the behaviour of students and how it changes. So, as I said before, it's not really if a student is clicking a lot or not clicking very much, but we need to understand if a student has started out clicking to some extent and then they deviate from that behaviour, then this is an indication that there may be a problem. So we need to really look at the individual students and to understand how that particular student learns, and possibly find, some way of classifying students in terms of a learning pattern that doesn't necessarily dictate how they should approach a course, but if we understand how they're approaching learning, if that learning is fairly successful for them, but then we can identify a change in their behaviour pattern, then this is a fairly good indicator that they might be having some kind of difficulty, and it's a good time to intervene to find out what the difficulty is. We have had some problems in terms of rolling out the results and validating them real time, because obviously the data sources at the Open University are quite large. They're distributed across different departments, and we don't currently have a data warehouse to house all the different data sources. A particular stumbling block is the VLE data, which we found to be very informative and very useful for these models, but it's a huge data set, so it's kind of like a chicken and egg situation. In order to integrate the VLE with other data sources for a data warehouse, we need to somehow decide which data from that set is going to be most useful. But without running some predictive models, we're not going to be able to say exactly what's going to be needed. Also, we need to understand exactly what the data means, and it sounds easy, but it's not always. When you're looking at a database table, it's not always easy to understand, and the knowledge about this data is distributed across the OU departments. So finding out exactly what it means to be able to do the interpretation can be quite difficult. And also module structures differ. So while some TMAs are compulsory, others might be substitutable. And you need to understand a bit about this in order to build an accurate model. You can build a model without knowing this, but it's not going to be as accurate as if you can include some of these parameters. So just to sum up very briefly, students work in very different ways, so we can't just find some way of saying student X is going to fail because they fit this particular profile. We need to understand that they can change their behaviour, but if they're on a learning path and then they deviate from that path, this indicates a problem. And as I said as well, it's also wise to be sensitive to the differences in the way that courses are structured, and also probably in the content of the course. So that's it. I'm open to questions.
Hi, Björn from Brandeis University. I was wondering if you did any grouping or sorting of the different types of clicks that you had in the system to see if one type of clicking was more predictive than other.
We did. We thought this would be very useful to identify the different types of clicking activity and then filter out ones that maybe added just noise. But actually, with the level of granularity that we currently have with the VLE data, we didn't get anything too informative by doing this. There was some clicking that might occur for doing non-learning activities, but it was so minimal and it seemed to occur so, uniformly across the data that it wasn't worth to do this.
I'll try using a loud voice. I tried some preliminary similar kind of analysis on data for a few courses. Found that the issue of what they were clicking on was really important, but it was an interaction between how the instructor used the course and how the students used it. So, for example, in one class, the more messages, just messages they did, that was negatively correlated with
Okay.
more the information, and of course, the more they clicked on assignments and used it in the assignments, the better they did. But that was kind of a no-brainer. You know, like you said, everything is really related to how they do in the assessments in the class.
Yeah.
If that were not the case, I'd be really worried about the predictability of the system. So there were really large differences in what they were clicking on in this particular case, in this type of system we're looking at.
I think that's really interesting because I think that goes back to what I was saying about you can't just have a one-size-fits-all solution, and that even in courses at the OU you probably find something quite different. So our findings based on our 3 data sets were that there wasn't worth filtering out different types of data, but we could even then go to another data set and find that actually forum activity on this particular one means something in this context, and then we need to start, really understand why. And this is the communication that we need to have with the people that are responsible for the data in a way, the module teams and tutors and even the students themselves, because you can't do this in isolation. You need to have, I think you're getting at some understanding of what these different data sets means and why, the explanation for it as well, why it would have an effect.
And I thought the next step would be to cluster classes according to what type of clicks are predicted.
Yes, yeah. That's right. That's something we're looking at now, is trying to find some kind of ontology for describing the different courses and how, what's going to be the factors to do that.
Yes, this is Laura from Marist College. I was wondering, the clicks are tied to modules, and the modules are, again, I assume, tied to instructors. How do you account for the variability of instructors that may have different approaches or different workloads? Did you do something like compute an average or average over all the courses?
You mean in terms of what the students had to do to pass that course?
Because we are the next presentation, and we had a similar situation with different students in different courses with different instructors that may have completely different ways of approaching the course. So
we were surprised that when we built a model and then applied it to a different module that we actually got very good results, because we think that probably there are these variations, and I do think that you do have to understand, or build an ontology of courses and understand something about the course and build this into the model to improve your prediction, because like you said, the burdens on a student is going to differ. I mean, in the OU it's done by module teams, so it's not really the tutor. The tutor really delivers the course, but the content of the course is decided by a team in advance. But obviously, between the teams, there's different ways of doing things and different ways of assigning the effort. Some courses might put a lot of effort into the activities, but other courses might really use very little. We want to be able to exploit both the data from both types of courses, and we need to understand that the model for one isn't necessarily the same as the model for another. We need to know what these parameters are. So.
Okay. Thank you.
Do you have time for one more question?
Jeff from Kingston Education. And I want to know, like, for this platform system, from which month we can input the students' click rate so to predict their whether at risk or not?
I'm sorry, could you repeat?
Like from week 1 or week 2, we can start use this kind of finding.
That's right. We found that it was pretty early in the course we were able to make a prediction. However, prediction does get more accurate as the course progresses, and I think that is inevitable. That's always going to be the case, because then once the course progresses, you start to have some information about the assessment data, how they're actually performing when they're assessed. Okay. But we were surprised that we could do fairly accurate prediction just from knowing that they had been sort of maybe clicking in the VLE and then maybe they stopped clicking.
Okay, and the other one is when you build a model, is there any performing period?
Any what, sorry?
Performing period, like if you input the students' click rate at a snapshot, and what kind of after this performing period, the outcome of their at risk?
I'm sorry, it's the microphone is...
Yeah, what I mean is, the student's data is at one snapshot, and we predict at some point there may be a risk.
Yeah, we were doing it on...
So what's the time horizon between the input and the outcome?
We were predicting at all different points during the course, but we were using windows to begin with of the TMAs. So it's not actually a fixed time window, but because the timing of the TMAs might vary. But we also looked at predicting on a week-by-week basis. But as the graph showed, you often get a peak of activity just before a TMA. So you really need to look at activity before the assessment is due, because you can do nothing right up until the day before you're due to submit, and then you can get active, and that can be your pattern. So you can't really tell that in the week, if you count the clicks the week before, then there might be not much happening, but you can't draw any conclusions from that.
Okay, thank you very much.